Coffee stains and name chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not a main thing, really I'm a coder. Coffee stains and name chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not a main thing, really I'm a coder.
Yo, chat, what's up? What's up? Let me turn this on. Adjust my lighting real quick. Oh, wait, hold up. Let me turn. What's everyone up to? Happy Saturday. Mim, what up?
This is not a main thing, really I'm a coder.
Happy Saturday. Time to grind. Who here did the contest? Yeah, I just got out the gym. This is not a main. Did you hit the?
This is not a main thing, really I'm a coder.
Did you hit the gym already? And we're gonna get to some resume reviews tonight too. Finally get to those resumes, those burning resume reviews that everybody been asking for. Who here did the contest? I need some people who did the contest and can help me out. I only solved 3 out of 4. Or sorry, 3. What happened to your car? What happened to your car? Just broke down? Need help. Need help. What up? What up? Who here did the contest? I haven't kept up with UFC in a while. I feel like I'm just not there's just not a lot of fighters that I like anymore. I used to watch it a lot. I used to watch it every single weekend. I used to watch every single big fight from like 2015 to 2022 or something like that. What's up? What's up? How's everyone doing? Who here did the contest? I need some help. Yeah, man. The cards suck. Can't lie. Like, who's the new star these days? Who's even the fighters? There's no real star fighter. Not as many star fighters anymore. A lot of the ones that was stars are just losing fights. A lot of wrestlers are champions right now. Yeah, I like Taporia. I like Makachev. I like, yeah, for sure. Lightweight was always my favorite division. Like prime lightweight was amazing. Yeah. Bo Nickel. Yeah, those are new guys, but they just need to keep building themselves up. Probably in like 2 to 3 years, if these guys keep building themselves up, it's gonna be super interesting again. I don't know. I just haven't had time to watch the UFC too. I was because all these contests are happening when the contest is or when the fight cards is happening. It's like, all right, who here did the contest? No one did the contest? I guess we could just read the solutions and figure it out. All right, it's all good. It's all good. We could just watch it and figure it out. What do you mean design problems? Yeah, it's always been like that. Well, I've always seen only a few types of problems. Straight leak code. Bro, my elo's getting got cooked from the last competition. I took a Div 2 contest and it dropped mine. So I was at 1152. Then I took a Div 2 and I got cooked and it dropped. So I'm 1066 now, which is trash. But in March I just completely lacked, but I'm gonna grind it out some more. Okay, so let's look at the man, there's no solution here. Alright, let's see who solved it. Let's look at some code. Okay, I see this guy's code. I'm just doing Codeforces grind to just be unstoppable software engineer in general. Oh yeah, yeah. Okay, so somebody here did it. I think I think it's improving sweet skills. Yo, Paul in the building. Yeah, I feel like give me a year or two, I'm gonna actually shoot for a quant. Yo, I got cooked. Yo, okay, Alpha and Paul are here. They can help me with this question. This is a math question. Okay, why you say it's easy to solve? Okay, I'll tell you my approach first. Because we wanted to construct n integers such that the greatest common divisor is distinct. Bro, I didn't solve it. The way I thought I was gonna do like 1, 2, 4, all powers of 2. That's one way to make them adjacent, right? Because the question is basically saying we just need unique. So this question is saying let's walk through D. So D was saying, D is asking first pre-compute all prime numbers and then take lowest common multiple of each 2 prime number. Interesting. Okay, I'll tell you my approach first. So and then we'll, I think that makes sense what you said there, and I'll draw it out. So we need to, it says construct a sequence A containing n integers such that, like, basically two distinct two adjacent numbers aren't, or two adjacent numbers calculate GCD, or distinct GCD over all adjacent numbers. So essentially they're going to give you, and then you need to, they're going to give you a desired length. They'll give you n desired length. So for example, when they said 3 here, so if they said 3, we need to construct 3 numbers that meet this, right? So 1, 6, 2 meets it, because what's the greatest common divisor? 1. What's the greatest common divisor? 2. So because GCD of 1 and 6 is not equal to GCD, right? Yeah, you need that adjacent have unique G. Yeah, so chat, the thing that I was thinking at first was, it's kind of stupid. I mean, it would work, but it just like blows up. It would be like 1, 2, 4, 8, 16, 32. Because this would just be 1, this would be 2, this would be 4, this would be 8, this would be 16. And then I was just gonna take that, and they would be unique GCDs. But then the number would just get huge. And I don't think it accepted it. So now let me look at the chat. What do y'all think about my stupid solution? Okay, let me look at the chat. Is for this to happen, the prime that the adjacent pairs need to have common needs. Yo, Dash, what's up? Okay. Somebody said first pre-compute all primes and then take lowest common multiple of each 2 prime number. So what are, so okay, so let's calculate some primes. 1, 2, 3, 5, 7, 9, 11, 13. These are all primes, right? One is not a prime? Alright. So lowest common multiple is the lowest multiple that divides both? Lowest common multiple is smallest multiple of both. Yeah, you're right. Dim. So what is this? 6? What's the LCM here? 6? What's the answer here? 3 times 5, 15. 35. 77. Why would this work? Shoot. Holy. So what's the GCD of this? 3? What's the GCD of this? 5? What's the GCD of this? Why would this work? Proof. Why would you have a unique greatest common divisor? I mean that might work. I don't get the proof for this, but I feel like it would work. Then the answer is P1 times P2. Okay, P2 times P3. Why does it have the okay? Yo, this is what like random people did. Um, what is this? I times I. Interesting. Okay, this is the actual solution right here. They found like some sequence. Chad, you want to know why this works? What the? Bro, this is like these guys must have looked this up. What is this sequence? Yeah, but this is different than that, Avon. This is different than what you're saying. What the solution you're saying, this is different. One times three, three times five, five times seven, seven times nine. Okay, that's what you're doing. We can just take product of consecutive odds. Why does that work? I see. Because we see that unique GCD and odds. Is exactly the middle odd number. Give me examples of the first five. Oh my god, what the hell? Okay, let me read this over. My approach for what? This is different. This is just this approach is taking product of consecutive odds. I don't know. I wouldn't have been able to figure that out in the contest. You take the product of consecutive odds. It works, Paul. That's what everyone's submitting. Yeah. I don't get the math though. So two consecutive odds. 1, 3. Now compute the GCD. Okay, both share this 2i plus 1. Oh, okay, I see. I see. They both share this factor. I see. Well, like, what's the math? They show like the how it breaks, how the math breaks down. Damn, you have to break. So you're saying this approach doesn't work? Y'all are saying this approach doesn't work? Hi, I'm a Filipino James doing this study for a system design interview while listening to sick. Welcome, James. I'm gonna get into some system design later, in probably like less than an hour. So yo, chat, all of y'all saying like this, these guys' solution doesn't work. There's some math. Okay, we'll move on to the next question. I wouldn't have been able to solve this. Yeah, how would the primes work? Damn, they ramped it. Let me ask ChatGPT 5.2. Oh, this one's using prime. Pair. No, I'm not live every day. I'm live a lot of the times on the weekend, but yeah. I thought I had something for. I'll show y'all what I was thinking for E. Yeah. So what does this actually mean? So I just need to learn this prime stuff, whatever. So we could have done primes or okay. Why does this work? The only common factor is the shared prime. So if we have two and it's a multiple, of the prime number. And the other one beside it. Yo, man, we're gonna get to at least expert by the end of the year, and we're gonna grind all the way up to grandmaster before I leave this earth. I have to be a grandmaster. And those are all distinct since the primes are. This solves it immediately. Okay, what am I missing here? I don't Denver. I don't get this part. What? I don't get this part. Dumb it down. 2 times 3 equals 6. 3 times 5 equals 15. 5 times 7 equals, okay. So this shares 1 prime with the next one. Why does it have to be primes though? Oh, I didn't know this. What? I don't get this one. Yeah, this is like the extra part. Every adjacent pair to have a different GCD. So for A1 and A2, A2 and A3, A3 and A4, we need, yeah. What goes wrong without prime? Suppose we try 2 random numbers. This one has a 6 and this one has a 6. Because numbers can share multiple factors and things overlap. A prime has no factors except itself. So if 2 numbers share a prime, that prime is guaranteed. Explain this further. Saying primes are special because a prime has no factors except itself. So if 2 numbers share a prime, that prime is guaranteed to be a GCD or part of it, and nothing extra sneaks in. Largest. Okay. So if two numbers share only 3, GCD equals 3. So 3 and 5, the GCD is equal. GCD 2, 3, 5. Using control, it comes a combo of factors. Three undivided by 3, 5. Okay. If two numbers share prime p, then the GCD must include p. Yeah, whatever. Just going over my head. Let's look at the next one. After looking at D, I was too burned out to really get to E. Who solved E? Yo, Caesar, what's up? What's up? Who solved E? Nothing much, just grinding out Codeforces. This competition was rough. Okay, so this is some XOR problem. XOR problem. So we're given an array A. So let's break down the problem. Yeah, Paul, I need to look that one further. That one is just straight math. So we're given an array A. Of non-negative integers. You may perform the following operation exactly n minus 1 times. So we're going to follow these steps. Select an index. Select any element. Select any element from the array. XOR every other element. And then remove it from the array. Maximize. The goal is to maximize the last element left. The initial length of the array, the second line of each. Yeah. So let's look at the second test case. Does that make sense? So we're given like 1, 2, 3. This in binary is 1, 1, 0, 1, 1, 1. So first we select the 3 and remove it. So XOR is pretty much like 0, 0. If we have the XOR, 0, 0, 0, 1, 0, 1. Sorry, go 0, 1, 1, 1, 0, 1, 1, 1, 1, 1, 0. So if we take the highest number, it pretty much zeroes these ones out. So select 3, remove it. So if we select 3 and remove it, we have to XOR all of these ones. So this becomes, so we get 0, 0. And then we get 0, 1. And then we could pick this one and get 0, 0. And then we finish off with oh wait. Select the element 3. Oh, this is, sorry, just like this. Select the element 3 and remove it. So if we select the element 3, we have to XOR this. So if we XOR that, we get 0 for this guy, because 1 and 1 is 0. And if we XOR this guy, we get 1. And if we XOR here, we get 1. If we XOR here, we get 0. Then we can select 2 and remove it. 1. So if we select 2 here, we're gonna end up with 1, 1, which is 3. So that's what the question is asking. I didn't know how I was gonna solve it. I was thinking maybe we could just take the highest. Yo, Ramen, what's up? Did you do the contest? Ramen in the building.
Oh, somebody! Oh, he needs some milk.
There's the question link. So what do we need to generate? Oh, we need to generate the final element. So if there's n squared, I don't think O of n squared will work. Get some water. Yeah. Type in the chat how you think it's gonna work. One. Okay. Yeah, you wanted an odd number of times so it stays on. Hit my knee. So what's the exact solution? We're saying, okay, I see Zor of the, yeah, because I guess we just need to look at, nice. Did you solve accounts merged using DFS or with union find? I like to do DFS. Just Zor the whole array. Keep track of the Zor of the whole array. Man, I miss leak coding. Questions like this make me miss leak coding. Damn, why is the Div 4 contest actually more difficult? So what's everyone saying? Okay, let's see what Alpha's saying. Conceptually, it's like the answer is the one that contains the biggest bit that appears an odd number of times. Someone came in and said that this was easy, but then left. So how do you maximize this? But this example is too large. I don't even know. Yeah, I might have to ask this to Chat GPT again. I don't know what the rate. This is like a Div 4 competition though. I'm just doing the ones that I couldn't solve. Some of the I was able to solve only 3, but it just got more and more difficult. Alpha, you running mocks today? Nice. How's the weather over there? The final number is always just this Zor AJ for some two original elements. So the whole problem becomes find the maximum Zor of any pair in the array. Let's look at what one operation does. If you pick a value x, every other element becomes value Zor x. Then x is removed. So picking x like flipping every remaining number by Zoring with x. So this is the answer. Let's see what like lots of people just one line this. Yeah, this is actually a man, it just gets harder from there. Well, all of these are one-liners. You just have to figure out the math. How many people? Probably a lot, man. Okay, let's look at the key insight. Cause yo, I feel like a lot of people cheated because how many people so many people solved this question. So we had like 7,000 people solve this question. 11,000 people solved the other one. Out of like only 20,000 something competitors. Like I feel like people are cheating, but I don't know. We just got to get better still. I don't get this. Value XOR X. Then X is removed. So picking X like flipping every remaining number by XORing with X. I don't know. Suppose you remove C first, then array becomes XOR C, XOR B. Oh, it's like some mathematical property. XOR identity. Yeah, you just gotta remember this stuff. Every so it's basically saying that every time you remove something, it contributes an even amount of itself. Damn, using a binary try. Okay. This XOR this equals 0. Okay. Okay. Oh, I see. I was practicing these identities like 2 months ago. Yeah, because when we remove it, The identity is x XOR x equals 0. Because if you have like 1, 1, 0, 1, 1, 0, these cancel out, these cancel because they're the same. And then obviously anything XOR. So since it contributes all of them, since all the XORs contribute, like if you choose one, it just cancels itself out. So everyone you choose kind of cancels itself out because they'll all end up at 0. So you just need to find the last two. Yeah, because then you're left with the last two numbers. But why does the last two numbers matter? Oh, because now we have B, and then we're gonna be left with A and B. Yeah. Could just if you apply C, then it counts because you can just pull out that factor. Yeah. Okay, what's your explanation? It's because what I said, like the X of everything gets XORed with X. Like this. Wait, let me read this chat GPT thing real quick. But does it need to be a odd amount of D's or no? Why does it get applied twice in the chain? I don't get that part. Okay, let me read the chat. It's hard to understand what the chat's saying sometimes, honestly. Just reading. Okay, so everything has D. So now, oh, because since it has D, any number we pick is gonna XOR it with D and cancel itself out again. Okay, I see. That makes sense. Because it Zors everything once. So we have D Zor, right? And then now we're left with this. And now when we Zor it again, it'll cancel itself out. Like if we pick C and D, it'll Zor the D will get here, but now these will have C. And then finally, okay, I see. Yeah, that makes sense. That makes sense. Holy, finally clicked.
This is not my main thing, really, I'm a coder.
Yeah, it makes sense now. It makes sense now. So it's just like you gotta just keep the terms. Okay, first. Okay, step 2. Now we're back at just with transformer values. We already proved that the 3 elements result Zor of 2 of them. So the final result must be some sort of D. Yeah. And then yes, yeah. Holy. All right, chat. I'm proud of us today. All right, let's go through some of the ones I actually was able to solve. Who solved C? Damn, you just gotta maintain the identity. How do you even come up with that? You just gotta remember, I guess to come up with that solution, you just need to understand Zor. And then you just gotta keep trying stuff out. I feel like you can't do this contest without having pen and paper. You can't do Codeforces without having a pen and paper. Yeah, the Zor identity is quite common. You're right. Usually when I have a pen and paper, I do way better on the contest. Cause then I just straight up just like, yeah, they're all just kind of math puzzles. I try using Excalijaw, but yeah. Sometimes you're just way faster without the Excalijaw, like just on pen and paper. So I think the main thing is just don't worry about the actual. I think the how I would solve this next time is don't think about the actual numbers. Just think about the identity, or yeah, just try to reframe the problem in terms of terms and try to use the identity or something. Like the actual numbers don't really matter. It's more just like that they're distinct ABC, and then that there's some identity. Yo, what's good? I see. Solve the first question. I don't know. I don't know what how it's gonna work. I don't know what my rating is gonna be, but yo, yeah. Yo, the Citadel interviewing guy is about to hop on in 10 more minutes, and we're gonna discuss the design that we built out the other day, like yesterday. I think I found like a good solution for it. Add me on LinkedIn and I'll connect you with that guy. Yeah. Yeah, I think I found a good solution for this. I'm gonna walk him through. Let me take a quick break. We'll be back on in 5 minutes. We'll be back on. We'll be back on back at 3 PST to discuss the design a remote IDE. Yeah, we'll be back. We're gonna design a cloud-based IDE. I have my solution. I'm gonna show it to my friend. I'll be back. We back. We back. We back. Yo, welcome back.
Oh, yo, what up? Yo, give me a sec. I'm gonna use the bathroom real quick.
All right, go ahead. Put some eye drops. Grind. Let's grind. Let's get it.
This is not my main thing, really, I'm a coder.
Don't y'all just love grinding? Man, this guy's cares more about his Anthropic than his Citadel. And they let him do Python. So, I think we're good. He wants to do more system design. I think he's good on the coding stuff.
Yo, man, the myth, the legend,
Yo,
James.
what up, what up, what up?
How's it going, bro?
How you doing? Just
Chilling, bro.
grinding this Saturday?
Yeah, just been grinding. My homie is in town, so I'm gonna go kick it with him after this. But then I'm gonna be back to grinding.
What are y'all up to? Just chilling?
Yeah, I don't know. He's just like, yeah, bro. Like, I'll drive up. We can walk around and shit. He's just coming for the weekend before going to Coachella next week.
Nice. Oh shit,
Yeah,
Coachella's coming soon.
Yeah.
Nice.
Have you been?
No, I haven't been. Hold on, let me get the lotion. Who's the guy? Is he chill? We're
He's
about to
all-
go eat
Oh, you're about to go eat?
with like Brian and Albert, all those two.
I could hit him up. Yeah, I could hit him up and see if he wants to join. He's chill though. Yeah, I can tell you more about him, I guess, like off stream. But yeah, he's very chill.
Is he a founder?
No, but he and I used to like go out together a lot.
Sick.
Yeah.
All right. So let's discuss this design a remote IDE. Chat's asking what role at Anthropic. It was a deep learning one, right? Or what was the role?
It's so technically it's a product engineer role, but it's on like an infrastructure team, like an ML infrastructure team for like one of their new APIs.
Nice. So, are you in the coder pad? Can you see?
I'm in the coder pad. Yeah, I'm looking at the problem. I
Can
think.
you scroll down a bit? Are they
we
gonna do
doing it-
Python or C++?
Are we redoing the whole thing?
No, I'll just explain like what I read and then let me know what you saw.
Okay.
Can you see down here? Yeah.
I can see. Yeah.
Yeah.
Wait. What's the Python C++ thing? This isn't like a language thing, though, right?
Oh no, they're asking what role at Anthropic are you gonna be doing C++, infra?
At Anthropic, I'm just doing Python, and I'm pretty sure the role is going to be in Python too. Yeah.
Okay.
Yeah.
Cool. All right, so let's just discuss this remote IDE. So how are we breaking this down? So what were the functional requirements again? Let's go through it. Functional, and then functional requirements was it's gonna be basically we're gonna have like some IDE. On the right side, we're gonna have some file system, right? And then we're gonna have like a code editor. And then we're gonna have a run button to run the code.
Yep.
So on the functional requirements, we're gonna have file system. We're gonna able to edit code, run the code. Simple as that, essentially. And this is browser based.
Run the code. We're not doing a terminal.
Why do we need a terminal?
Because it's an IDE, right? Like you know how in VS Code you can have a terminal and you
I,
can run other commands
or
and
I
like
guess like
install files and
let's
stuff.
say we're designing Replit then. I think
I think even in Replit you get a
okay.
terminal. But let me see.
Yeah, let's handle that case later.
Okay.
No, chat out. We're just going through it. We already did the question before, but we're just discussing it. I'm kind of going through my thoughts now. Or terminal. So essentially those are the functional requirements. For non-functional, we wanted it to be more just available than consistent because there's not really two people fighting for the same resource or anything like that, right? So we just want we'd rather the site up constantly, and it's not like a banking application or a Ticketmaster or anything like that where there's a chance that something's gonna get double booked, or there's no real issue on the user side if things are eventually consistent from what I see. That
Technically, if there was like multi-editor stuff, I mean the file like syncing, right?
yeah, that's true. But okay, let's go available over consistent for the cap theorem. And what else? We want it to be secure. Means like can't run code. And if let's assume we have a lot of users, scales to I think we said 100 million users or something like that.
Yeah, yesterday said 100 million, which is pretty crazy, but yeah.
So yeah, so we'll probably have to do some sort of horizontal scaling. What are some other non-functional? We want it to be available, secure, low latency. So when we run the code, it's low latency. I think yesterday you said under 100 milliseconds, but one thing to consider here is like how fast can humans perceive anything. So I think if it's under 300, it doesn't humans can't really perceive that latency. So there's no point in making it any faster.
When I was looking online, it said under 100
Oh,
milliseconds.
okay,
Like
that's what they said.
yeah, yeah,
Okay,
yeah,
that
yeah.
humans could perceive it.
Under 100 milliseconds, humans can't, and then they chose 50 milliseconds when I was reading.
Okay, okay.
Yeah, but up to you. I mean, you're the expert.
No, I don't know. I think it would just like figure out what's like it doesn't make sense if humans can't perceive it. You know what I mean?
Yeah, yeah, yeah. I agree.
Listen, like around 100 milliseconds. Yeah, we'll say less than 100 milliseconds. Otherwise, low latency, and then yeah, I think just low latency in general. So that's kind of the non-functional requirements, and I think for this kind of question, I just realized that it doesn't really the API design doesn't really matter as much. It's more about the system design, more about the high level design and how the components work together. So
Yeah.
yeah, that's what one thing that I would try for next time is like for some questions maybe modeling the database is more important, but some it's less important. So you should like as a candidate figure that out, and maybe the interviewer might push you towards one way if he really wants to see. But I think for this question, like the database design is not that important.
I guess in that case, like when you're trying to make that decision, like how do you like what would be a flow chart to think through that, like whether or not you need to prioritize the API or the high level design more.
I would say like pretend we said, oh, design recommendation system or design consistent hashing or design a rate limiter. Then you just know that at that point the database or data modeling is not really that important for that
Yeah.
case. But if we're like design Yelp, then that's like just straight
I
almost a
see.
CRUD app.
Basically, the closer it is to infrastructure, the less the API and like database design matters,
Yeah.
and the more the high level design matters.
Like every problem is interesting in different ways. For some problem, it's interesting to talk about how we're gonna design it, like Google Calendar, like design the database and the tables. But then the infrastructure is not really that important. It's just CRUD. So there's no point in staying so long on the simple CRUD. But this one's more interesting on how we're gonna run it. So I think as the candidate, you should mention that and try to guide it into the more interesting part. Because if you spend too much time on the parts that are not interesting, then we'll never get to where you want to be.
Yeah, yeah, that's fair.
So I think with the entities, we'll just talk about it at a high level. We will have like the workspace, like you mentioned. That's kind of like a project in VS Code, and then we'll have folders and files, right? And then that's pretty much it.
So I guess like maybe we're getting ahead of ourselves, or maybe I'm getting ahead of ourselves here, but um, so yesterday I made that decision to have like these entities and stuff. But I think whether or not you need it really depends. Like whether or not you need the folders and the files and stuff kind of depends on how you plan on storing the data, right? Like
Yeah.
if you just keep it in like persistent block storage and then you attach that to your virtual machine, then you probably don't need to be as fancy
Yeah.
here, right?
Like yeah. I think the reason why we'll need the workspace and folders is just so if the person refreshes or comes back later, we can rebuild their workspace. So workspace is kind of at the top of the hierarchy and then it has folders and files, and then files will point to actual, well, we could store the files as like you mentioned yesterday as directly into DB or just a URL to somewhere in S3 that points to the file. But files will be sort of the leaf nodes, and folders we don't really need to store actual folders. I think we just need to understand the directory structure.
But then how are you gonna like? It's the same question that we talked about yesterday. Again, maybe I'm getting ahead of ourselves here, but like, how are you actually gonna keep that in sync with
Yeah.
the what you're executing?
Yeah, I'll get there.
Okay.
So let's walk through our functional requirements. We're gonna have a file system. We're gonna be able to edit code. I think we need to be able to. So let's just go through creating workspaces. So we'll be able to post workspace. I'll just since the APIs aren't as interesting, I'm just gonna have it at a high level and we'll flesh it out after. But for post, and we should be able to get workspace. And when we get the workspace, it should just load in recursively, probably all the folders and files. I don't think it really makes sense to like get one folder at a time. It should just return you the whole project so you can build it up on the front end. So that's with the workspace, and then maybe okay, I guess let's just talk about the high level design first, and then I'll talk about the APIs because I think it'll make more sense once I show the high level design. So we have our client, and I'm gonna just have a very simplified design here. But essentially the client, there's gonna be two things that's happening. We have our client, and the client sees this file system, right? So let's just say we're gonna have the client's gonna have this file system, and I think we're gonna do two things. We're gonna one periodically backup state of the client to S3. But then also that's gonna happen. There's gonna be two things happening. One, periodically backing up the state of the client to S3, and then client directly um, sending changes to some container. I think definitely we want to. One thing is we want to run the code in a container, because just for isolation, and we don't want to run it on on our application server. We want it to run an isolated container, and then we could like add its own dependencies, and it's isolated from all the other containers. That code that's running is isolated from all the other code, or all of the other users trying to run code. So we're gonna be trying to run it on some container. This is gonna run the code, or we're gonna have, let's just call it like this. It's gonna be a big box because it's gonna maintain multiple things. So this container is going to be running the code, and what we're actually going to want to have is our file system here. So we're going to have our workplace. So it's going to, here it's going to actually just have the files here. So workplace, direct1, direct2, and then the files. So when we decide to run the code, everything's already in here, and we just run it. And in the container, we can choose whatever execution environment we want, Python, whatever. And we could just kind of run like Python, and we can install all the dependencies in here too. But it's going to be in some container. That makes sense so far? This, like, the client is eventually going to run this, but we still didn't talk about how the client is going to push files and make it run. But we'll talk about that. Does that make sense so far?
Are you asking me?
Yeah.
I mean, you're basically saying you have a container that the client connects to. Each client has their own container, right? It's one-to-one.
Yeah, in the most basic case right now, yeah, it's one-to-one.
Okay. And are you? I guess like we don't need to like how is it too complicated to get into like how are you connecting it? Like, are you doing HTTP versus WebSockets basically?
Yeah. Okay. So what we're gonna do is so on the container, right? We're gonna run another process, probably called we could just call it like what should we call this? VM agent or something. So what this service is gonna do? It's gonna be it could be like a REST API, or some sort of agent, but it's gonna receive commands, and then it's gonna update files. It's basically gonna have control of SSH commands. So it's gonna be able to patch files, create directories, etc. This is what this agent is gonna do, and it's gonna have like a clean API for updating the files on the work system, then running the code, and then streaming the response.
When you say agent, like what do you mean by that?
Or VM server. It's
Okay.
basically just, let's just say we just have some server running on the container, because the container, in order to talk to the container, you need to connect to some service or process, and that process needs to expose itself on some port so you can communicate with it, right?
Okay. So it's client direct container, right? It's not client to like a control plane that manages relationships with all the containers.
You can think about it as like just a HTTP server just running. We can
Within the container.
we can just say this is it's running within the container, and essentially, and then let's build out this a little bit further. So what we're gonna do is, so we have a client, right? We're gonna have a load balancer, and then the load balancer is gonna connect you to a few different. Well, since we're gonna vertically scale to support the 100 million people, we're gonna have different. Let's just call these our code, or app server. So we're gonna have like a bunch of different app servers. So the load balancer, what we're gonna do is we're gonna talk to the load balancer. The load balancer is gonna connect us to app server, and then we're gonna establish a WebSocket connection here. So for real time, once the WebSocket is established, then we just talk directly to the app server. Like there's no reason, it doesn't need to talk to the load balancer again. Load balancer is for just load balancing the number of WebSocket connections across all app servers. So essentially, as I make changes, right, I'm going to send the change to my WebSocket, to the app server, and then the app server is going to communicate with the VM and tell it what to do. So suppose I update a file and like add hello world to line 1 of 2.5. As I make that change, and it doesn't need to, honestly, it doesn't need to happen that often, because also we only care that it gets on the server when they run the code, right? So it's not like it needs to happen it needs to get on the container as soon as we write the code, because it only really matters when they click run. But periodically, it's still nice to keep it in sync, so it's not just like one big update. But essentially, we'll push something like this to the app server, and the app server will connect to the VM server and make it update the file in the container. Does that make sense?
What's this app like? Why do we need this app server in the first place?
It helps us connect to the right container, and it manages that.
So this is managing which connection each client is supposed to, like which container each client is supposed to connect to.
Yeah, so the app server is figuring out, is making the connection to the container. And you're like, instead of the client directly talking to the container, the app server is talking to the container for you. So you send changes to the app server, and then the app server will propagate that to the container.
Doesn't the so what's this WebSocket connection for again? Like, because you're sending this message to the server, but when the server is sending it to container, that's also a WebSocket connection, right? Like there needs to be a WebSocket connection.
It doesn't need to be. It could just be like a gRPC, it could be HTTP, it could be whatever. But this is like, this is the client code, and this is our internal code at this point.
I see.
Like this is also for safety. We don't want them to just have full control of that container.
Okay.
And now with the app server, we can validate what they're doing before we send it off to the container for it to run as well. We could validate some of the actions that they're doing.
Okay. But we haven't gotten to running the code yet. We're just talking about editing the code, right?
Yeah, well, it's the same. Like as we write code, we're writing WebSocket, or like periodically we're updating the container with the code, and then when we click run, the code should already be in the container, and then it's just as easy as like the files are there. We just run it within that container.
And we're not streaming the output, right? We're okay with latency on the output coming.
No, we can stream the output. So that's what. So when the web search, so suppose we click run now. Suppose we click run. All we tell this guy is run, and maybe some input if there's an input. Then it just calls app server. It just calls the container to run, and then what it's gonna do is, if it's gonna run Python 3 whatever, and then foo, and then maybe like the parameters that you put in there, and then it's gonna stream the output to here, and then it's to the app server, and the app server is gonna stream it back to you.
But that streaming has to happen like through WebSockets is kind of what I was asking about, right?
Yeah, it can have. I think gRPC could stream it as well.
Oh, really? Okay.
I'm not sure. But yeah, it has to happen somehow. There's Yeah, I didn't look into that, but yeah, we'll probably want to stream the response from the VM server and then stream it back to the client. But does that make sense so far, like that architecture?
Uh, Generally, yeah. I mean, which functional requirements have we talked about so far? We talked about having a file system, editing the code, running the code.
Yeah.
Technically, you don't have a terminal, but I mean, this would also work if you had a terminal too.
Yeah.
Um, yeah. Okay.
Because then whatever terminal commands they run, we just propagate it to the VM server, and then we just stream that output back.
I guess
So
the. Oh, sorry.
yeah, go
What
ahead.
were you I was gonna say like so. I mean, this makes sense as like a one-time thing. You're basically just saying we have like the client connects to some remote container, and then that container connection is managed by an app server for security reasons primarily. Um, and but that works great in a one-time case. But what about like persistence? I guess like of the
Yeah.
files, like when you're reloading the workspace.
Yeah, exactly. So we have this client, it's talking to a load balancer on this side. We can call this our container gateway. This kind of container. Yeah, we'll just call it a load balancer for the container side. We could have a separate CRUD service for actually just persisting long term. So we could just have a file service, and this talks to our DB. And then we could have like we could just back it by S3 as well, like the actual objects. But essentially, periodically, the client, we're gonna have like some gateway here. The client is also going to like asynchronously. It's gonna send it off in two ways. First, it's gonna send it into, we could call this like some. So in this path up here, this is where we're periodically gonna store the state to S3, right? And then down here is, so it's kind of like duplicating. So periodically it's going to send the file, it's going to send the current state, it's going to go into the file service, the file service is going to write into the DB, write into S3, etc., and link them. So that way that it maintain it, we remember, if we refresh, what we'll do is we'll load the files, and then we'll put them into the container. Or maybe the container can just fetch from the file service when they load the workplace for the first time. So if the app crashes, yeah, if the app crashes, we just load up from the last time it was saved. It's similar to like Google Drive or whatever. Like if they don't, pretty much if they click Command Save or Save, then it'll perform this thing up here, and save it to S3. Otherwise, we'll just do it periodically. But like the changes that they're making down here, we'll try to stream it to container as much as possible. But honestly, it doesn't really matter when we stream it to the container. It only really matters when they click run, because when they click run, we need to make sure everything on the client gets on the container. But we don't want to do it all at once, so we would do it periodically, like maybe every 5 seconds. We'll be moving some of the files over. Does that make sense?
Um, so when you're sorry, I think maybe I missed this piece. Like when you're like let's say that they like leave that workspace or whatever, they like go and do something else on like a different website or something,
Yeah.
and they come back the next day and then they reopen that workspace. How does that information get pulled into your container? Is it like it's stored, is it persisted within the container, or is it persisted within S3 and then you use that same logic that you would if it crashed somehow to like pull it into
Yeah.
to pull it into your container?
So you could think about this as long-term store.
Okay.
This is like SSD.
Yeah.
It's always there. You could think of this as just RAM. The moment the moment that this thing goes down, we lose it. this container, right? But periodically, we're going to be updating the long-term store and also ensuring everything's on our RAM.
Okay.
So essentially, when this goes down, let's assume this, let's assume the container gets gets taken down because it hasn't been used in a while. The client is going to come in. It's going to ask the app server. And also one thing I mentioned is the app server, we probably want to maintain some Redis cache where we have like workspace to some IP address, which is the container. It just maps the workspace to IP address. So when a client comes in, it will ask the app server. It will ask the app server, where's the IP address of my container? It doesn't exist. So it's gonna spin up a container. Well, we could show that's like a different process. It could even be like another service that spins up a container and returns you just the IP address, and then it'll spin up the IP or spin up a container, and then it'll use the workspace ID and the data we modeled to just like restart the container with all of the files from the last time we saved.
Can IP addresses like for the containers change though? Like, isn't it somewhat ephemeral?
Which one? The IP address?
Yeah, like isn't the IP address of the container like somewhat ephemeral?
Yeah, it's gonna disappear at some point. And then if you try to hit it and it's not there anymore, then what we'll do is we'll spin up a different
Spin up a new one. Okay.
container. And then every time a container starts, we can have it just query the file service to figure out how to build the workplace there. And then now they're in sync when it starts, and then we start the process all over again.
Okay. So the S3 is like this entire like upside like upflow is just for backups basically.
Exactly.
And then this is for like when the client is actually using it. And then the app server will just call the file service in the case of like the first load of the file system, or if it goes down, basically.
Yeah, what we could also have, and I saw this on some other designs, it's more complicated, but we just have a container service. This job of the container service is to just spin up containers and instantiate them with the correct dependencies, etc.
Isn't
So,
that what the app server already is though, or is the app server like more than just that?
well, we want to keep we want separation of concerns, right? We want the app server to just do one thing, which is maintain the WebSocket and like act as a proxy for commands, forwarding commands to the container and streaming results. For spinning up a container, there's going to be a lot of logic. So let's say the app server noticed that the IP address no longer exists, is no longer healthy, or the workspace doesn't have a mapping, then it'll call the container service. The container service will do all this work to spin up a container and load it with the right files, and then just return an IP address to the app server. And now the app server could make this mapping of workspace to IP. And then now every time you talk to it, it just knows to forward it directly to the container. Does that make sense?
Yeah. Yep.
Yeah, that was the design that I was seeing when I was doing some research.
Yeah, I think I got something similar. Like yeah, having this like proxy server basically to manage the connections with the containers. I think something that I guess you haven't explicitly stated here is that technically like the storage here would be like block storage. And I think again, like something that's slightly different in the designs that I saw is that that block storage for the workspace would be persistent itself. And then the S3 would still also get written to, but it would only be used in like an emergency like backup kind of scenario. That's kind of what it seemed like.
Yeah.
Uh, but it seems like in your case, you want the memory to be ephemeral too, within the container.
No, like this is a container, and as we make changes to it, so it's just gonna be like a Docker container. You can specify the amount of memory. Because someone asking in the chat, where do we store the files in the container? What do you mean? Like the container, you can think of the container as just like a virtual machine, or some sort of. It's just a computer. It has its own file system. It could run SSH. You could run it like on Linux or whatever. So it has its own file system, and then you could just when the client makes changes, you just tell the container to like patch certain files, delete certain files. It just you could just tell it to do those SSH commands. So this is like a Docker container, and you could specify like you pretty much mount a volume. So it has its own file system. It acts like a computer. Did that answer your question or no?
I mean, it's just like what you're saying is a little different from what I saw online.
What did they say
Uh,
online?
I think what they said online was just like the virtual machine is only for the compute
Yeah,
and like operating system and stuff, and then the storage is like using what's called a volume,
yeah.
and then the volume is like block storage that's persistent. The container is ephemeral. It gets spun up and spun down, but it gets attached to the volume, which has like the user's file system and like all of those files, so that you don't necessarily need to read from S3 every time you're loading it for the first time. You just
Well,
load it in block storage.
okay, so you're saying the container is only used to run the code, right?
Basically, yeah, the container is just like a CPU, and then the memory is like the volume,
Yeah,
and
but
then
but
you
but the
attach the
code
volume.
needs to be on the container in order for it to run. Like if you want to run some Python files, all the files need to be in there in on that container for it to
I
run.
mean, again, I don't know. Again, like I'm not that technical. Like,
Mm,
I don't know the exact like syntax of how this all works. I just know that it's two separate entities. One is the CPU, which is what they call the container, like the virtual machine,
yeah,
and then there's the volume, which is like the disk, and then you mount the disk to the virtual machine, or like your
yeah,
effectively your CPU, and then you run those commands on
yeah,
top of
yeah.
that disk.
So like the volume exists inside of the container. That's what it means.
No, I think the volume is separate. It's like block storage.
Let's see.
It's like a block storage, and then you pull, like, you would technically have like another um uh like data model in your database that maps that like maintains like the IDs of the block storage, and then you'd pull that when you're loading, and then you'd pull which volume you need for that user's workspace, and then
Okay,
that gets like
like what?
attached to the VM.
Let's ask ChatGPT quick just to make sure. So when you have a container, does the volume exist in the container? Right? Is that kind of the question?
Kind of. Yeah,
Okay,
it's on.
Eliza said, but is mounted in
Yeah,
so it
that's what I'm saying.
appears.
Yep.
Okay,
Yep. The container is ephemeral. The container is not, or the volume is not. Yeah. And then they get mounted.
so
Yeah.
think of a container like a temporary machine and a volume like a hard drive you plug in. Okay, volume. Oh, okay, I see.
Yep.
But where would that live? I feel like it would still live.
Block storage. It's called block storage. I don't know. You can ask ChatGPT about that too, but it's called block storage. And then you maintain like the metadata for the ID of the block store when you load in, and then you just find that block store for that workspace, and then you load that in and mount it on top of your virtual machine.
Oh, I see.
Yeah.
Okay, so the container is kind of accessing it, but it doesn't live on the container.
No, yeah.
Okay,
It's like it's like what it said in
I see.
ChatGPT, right? When you have a PC, you can have the motherboard and the CPU and all that stuff, and it can run commands and things like that. But then you actually have to plug in a hard drive, like if you want to have
Yeah,
memory. It's like something like that.
that makes sense.
Yeah.
But like, how does it get? So the files never get into the container.
Uh,
Okay, but they're not actually stored. The container can read write files. So my volume set the container. I think yeah, this is just like I
yeah, we're
think
getting into the nitty gritty of how it
I
works.
think in both cases though, it's ephemeral. Or how do you say that?
Ephemeral. It's not
Ephemeral,
ephemeral
sorry.
for the block storage. No.
Wait, so how could you talk about your approach then? Let's see.
So I
Ephemeral.
mean, it's almost like the way you did it is almost the same as the way I had it in mind because you're using virtual machines, which makes things a lot easier. If you make the relationship one to one, it makes things a lot easier.
Mhm.
The only real difference is that from what I was seeing, you can just like this. This is it's kind of like as far as I understand, it's like would be um this would be like block storage. And then you'd have like block store or something, or like a volume, like I don't know, like I guess like workspace volume, something like that. And then you'd have like the volume ID or something, and then metadata, and then dot dot dot. And so then when you have your like container service, I guess the container service would then like hit this specifically when it's pulling it out, and then it mounts on top of the on top of the workspace.
Okay, but then how do updates happen?
How do updates happen? Like, what do you mean when you write files?
Yeah, or like when you make changes.
Um, I mean, I think that let me pull up the design that I found. Hold on. So so the way I understand it, uh, I can share my screen if you want, or I can just write it. I guess in the thing. Yeah. So you have block storage, the dev box. Yeah. So I think the way it would work is when you're making changes, uh, the app server, I believe, would just write to the block storage. So the app server makes command when it makes like write commands,
I
you're
see.
actually writing to
Okay.
block storage. And
What's
when it
block
makes like
storage
run
though? Is is
commands,
that is that like is the block storage like
I guess maybe it's more specifically, it's like this mounts here. So this container mounts onto the block storage, and the block storage
I see.
is like pulled again, like the yeah, which container or which block storage it maps to happens here. So this would be like find
I see.
or find volume. Yeah, find volume. And then yeah, there's one to one volume to workspace. Yeah, something like that. But this is more of a semantic thing. It's like the high level of your design and my design are basically the same.
Yeah. So
Yeah.
basically, as we make changes, the app server will update the block storage. But then when we run, since it's mounted, yeah, I guess we don't really need to send it into the container. We just store it in this block storage. And then when we run the container, it has access to this block
Yeah.
storage or it's mounted on the block storage. So it just runs whatever in there. That makes sense. Because
Yeah.
from its perspective, yeah, yeah. But at the end of the day, it's just like we write to the app server, then it moves it to the block storage. What is this block storage though? Is this also like disappears or no?
The block storage is persistent. The block
Block storage
storage
is
is
persistent.
persistent. Yeah. Which is why with S3, the only reason you have it is really for backups. Like I was trying to figure this out before, like why do you even need the S3 at that point? I think it's just for backups.
Are you sure it's gonna be persistent?
Well, that's what ChatGPT said.
Like,
ChatGPT said the block storage is persistent. The containers are ephemeral.
okay, what database is it then? This block storage. Like what
I'm not
solution is it?
sure. You could ask. That I didn't get that far deep before our call. Um, it's probably just SSDs hosted somewhere. Uh, Amazon EBS, a high performance raw storage technology used to host databases. It breaks data into fixed size blocks to store files, enabling low latency random read write access, ideal for transactional databases.
Yeah, this makes sense too. Yeah, you could just mount it on there. Yeah, this is a more sophisticated approach. I think at a high
Well,
level, or go ahead.
it's not a more sophisticated approach. I think it's just the same as what yours is, but like fleshed out to be more specific about like where the data actually gets stored in the file system.
Yeah. Okay. The one that I had, I think, yeah, my approach was slightly different. It's take the app server and then send it to the VM and get the VM to update the file system, and then have it run. It will just have its own file system.
Can the VM even have its own file system? Like, is that even like possible?
Can the
Like
VM?
without having, yeah, like does the VM implicitly come with memory?
Usually, let me look it up.
Like, because yeah, I mean, or I guess what's the trade off is a better question. Like, what's the trade off? Is it just like you have a higher likelihood of data loss? Like if it just randomly crashes on you?
I think the trade-off might just be just simplicity at this point because yeah, I think mounting it on some more persistent store makes more sense. Let's see. Cost, chat saying cost is the trade-off. Let's see. Yeah. I don't know. I think we have a good design there though. Like in general, like and then the couple of things that we need to add there that you could what if you I get asked in an interview, you could just bring it up. Well, we can just mount it or we can wait, let me or we're gonna ask it a question, right? We're gonna say
We could ask, yeah.
can containers have memory? Let's see. Yeah, but it shares the memory in the host machine.
It shares the memory in the host machine. Let me see.
So
Sure.
when you have the container, it runs as its own. It runs in like you can run the container, but then it uses the memory of the host machine. So suppose I'm running container in my on my computer. So my host is my MacBook, and then pretty much the memory is the SSD, and I could just mount some portion of my SSD that the container has access to.
I see, I see. Um, okay.
But this time, instead of having, so that's kind of how I was thinking about it. We're gonna have some host computer, and it might have multiple containers, but that host computer has its own memory, and it's gonna be running Docker or something. And within that host computer, it's gonna have different a file system, different files on that computer, and then containers have access to their own files, their own directory, and then we just mount that directory onto the Docker container.
I guess what's the need for having the block storage then? Like, because you said it makes more sense to have the block storage. Like, what's your opinion on that?
Well, if the computer restarts, or like the host computer is just gonna have so many files, and if the host computer goes down, then we lose it as well.
I see. So basically, the cold start time goes down if you just have to connect to the if you just have to mount on top of the persistent storage rather than having to move all the files around and reload them. Is that maybe what the advantage is?
I'm not sure. Let's see. So let's ask ChatGPT. So we're designing a system like Replit. We want to run our code on a container. Should we send the files to the container, or what's your other?
Should we send the files to?
Or
oh, it's basically should we be running the file system directly on the container or using a volume that we mount onto the container?
Should we run the, say it again?
Should we run code against the file system of the container's machine directly, or have a separate volume that we mount the container onto?
Should we run code against the file system of the container, or mount
The
an
container onto a
external
yeah,
volume, which is an external blob store, you're saying?
block storage, block.
Okay. A mounted workspace volume, if you can provide real file system. I don't know. I think we're getting into the semantics. It's
You
kind
said
of the
blob,
same.
not block, but
Oh,
yeah,
sorry.
it's all good. It's all good. I think that's why. You can just edit the last command you sent instead if you want.
I think it's just semantics. I think both approaches might work.
Yeah.
Yes, running code against a mounted external volume makes a lot of sense. You're choosing between containers writable file system. The better default is run against the mounted block volume, not the container's own. Why? Tied to the specific container.
Yep.
Not easy to move between runtimes. So a mounted block volume gives you persistent. Okay. Okay, I see. So it's essentially if you spin up another container, it doesn't lose it.
Wait, scroll down. I'm curious. I feel like it's mainly cold start time. It must just be cold start. No, I guess not. They don't talk about that. Maybe not.
Yeah, I didn't think of that. That makes sense. This approach.
Yeah. I mean, both are fine. I think it just depends on how ephemeral the containers are, like how much they go down and how hard it is to move the files around from S3 all the way to the container. Or if because it's probably faster to just mount onto the block storage. But they're both the same approach, just slightly different.
What else did we talk about yesterday that we didn't get to, or did we cover everything for this?
I think this is largely it, because you already also talked about like how to do the WebSocket stuff and moving the commands around. We didn't talk about the we didn't talk about the actual like APIs of how you do the commands and stuff. But yeah, I mean, according to you, that's not as important. So
yeah, I think I would just say that to the, because I thought about it more, and just a general rule with the system design is you want to, especially if you're gonna be senior, also is guide you, and you need to guide it. You need to guide it to the more interesting parts of the problem. So if we spent all the time modeling the entities, I think the funner part was how are we gonna run this container, even the mounting the volume and all that stuff. That part's more important. We don't want to waste any time. We only have 45, 50 minutes to get there.
Yeah. I think so you've been talking about using this as Docker, which I think is correct, or like either Docker or I guess Kubernetes. I saw some other, and I was looking at, other ways of doing it. There's like, there's somehow they're using Kafka sometimes. for managing some of the sandbox environments. I guess we don't need to talk, and like warm pools of containers. Like I think there's all these like technical semantics that we
Yeah.
technically aren't going into for deep dives, but I think for the high level, this is
Well,
probably good.
what's Kubernetes? Isn't it just like a container orchestration framework?
I think so, dude. I don't know what I barely
So
even know what
what
Kubernetes
it
and
does is it's kind of like a parent that spins up multiple. It just manages a fleet of Docker containers. I'm pretty sure.
I see. Okay.
So yeah, it just suppose like we're running. Okay, let's look this up. What is Kubernetes in 3 sentences?
No, I think you're correct about that, about the relationship.
Each pod is basically Docker or an app server.
I think technically also if we're using Docker and we're not using like an actual virtual machine, then then we still have to worry about security concerns, right? Because they can be shared by multiple people or no.
Sorry, can you repeat that?
So with if we're using like Docker and we're not using an actual virtual machine, uh which like has its own operating system and stuff, I think we still have some security concerns, right? Because with I think with Docker, it's a container. It would be sharing an OS and sharing like memory with other processes, like other users that are also running workspaces, right? Like, don't we need to worry about? Do we need to worry about that or no?
If it's sharing memory between.
Yeah, like it's running on the same operating system and the
Yeah.
same like memory, and so I think we might have to deal with like the same user running on like the same machine as another user,
Yeah.
unless we're using a full
Shouldn't they
virtual.
run isolated? There's probably ways
I
to.
don't know how that works. I mean, ideally they would run isolated, but they're going to be on the same machine if you're using containers. I think if they're a virtual machine, then they wouldn't be because it's heavier weight and it's like its own
Yeah.
operating system, its own
But
memory.
yeah, but then it's just too much. It's too heavyweight per, like if we have 100 million users, they all have
Exactly,
full
I agree.
computer.
I agree. That's why I'm bringing this up. Like how
If
like is
we
there
have
like how do you need to
multiple
like split that so it's secure?
running on a host, are they isolated? Yes, containers on the same host are isolated, but it's important to understand how strong that isolation is. So the same processes are isolated, their file system is isolated. We can give their own network isolated and the resources. Is it secure to have two containers from two different clients running?
Oh yeah, it says you typically add Kafka or Firecracker up there. That's what it said.
Containers share the same host kernel. Okay, yeah, at the hardware level, it's not. So if they can escape, they can micro VMs,
Yeah.
sandbox runtimes. So it's kind of just like another abstraction on top of the container. It's
Yeah.
like containers is more lightweight, and then there's like something in between a VM and a container that adds more security, more isolation.
I guess so, yeah.
But then you could also harden containers by doing all this extra stuff. Can you just look out? Like have better settings? No, this is a fun question.
Yeah.
Yes, you can harden containers a lot. Okay, I think because yeah, we're running people's. If we were running just our own code, like our own, it was our own server. It's our own. It's internal. Then we don't care to add that extra layer of security, because we're not gonna have like two different companies running on the same
Yeah.
host machine.
Yeah.
But since we're running two different people, then we'll want to introduce. So I think yeah, that's good to mention. Cool. All right. Good stuff. You want to do another one tomorrow?
Yeah, we can try doing another one. Yeah.
Go study some. I'll message you. Study something else.
Yeah. Yeah. Let me know.
All right, man. Thanks for jumping on. That was fun.
Of course. Yeah. Are you guys still gonna? Are you gonna keep streaming, or are you gonna go out?
I'm gonna stream later. I'll go out. I'll message you though.
Okay. Okay.
Okay,
All right. Yeah. Because my boy's almost here. So just let me know if you still wanted to kick it.
Sounds good. All right,
Yeah.
man. Catch you.
Later, man.
Peace.
Yeah. Later.
Yeah, ramen. These are pretty fun. These are definitely more fun. Yeah, I'll start doing these more. Don't worry. But I still have to grind out that Codeforces and Leak Code because I promised it myself. I'm gonna try to balance both though. But thanks everyone for tuning in. I'm gonna go eat. Then I'll be back for I'm gonna do the contest. Then I'm gonna stream resume reviews from like 9 to 12. So we'll see how that goes. Thanks everyone for tuning in. Catch you later today if you hop on. Yeah, we can do an AI system design question also. Am I good at networking? Just hop on at 9 PST and you'll figure out how to send in your resume. It's usually through my website. All right. Thanks everyone. Catch you.
This is not my main thing, really I'm a coder. Coffee stains and in my chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Leak code, beast mode, 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 leak code, beast mode. This is not my main thing, really I'm a coder. Coffee stains and in my chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Leak code, beast mode, 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 leak code, beast mode.